Topic of my dissertation was the use of Benchtop NMR to analyze alcohol levels in a range of beverages. This study shows the difference in concentration of various alcoholic beverages measured by two different instruments: nuclear magnetic resonance spectroscopy, which is known as NMR, and a gas chromatography with flame ionization detector, known as GCFID. Alcohol is an organic compound with a general formula ROH, while R is an alkyl group. The most used alcohol is ethanol. Ethanol is made for consumption in strictly regulated amounts. Its molecular formula is C2H6O. Ethanol is the main alcoholic ingredient used in the production of alcoholic beverages. Ethanol is also classified as a sedative, that's why it's considered the most commonly used drug in the world. Production, consumption, and sale are subject to strict legal restrictions. All alcoholic beverages tested in this study are homemade. Alcohol used in the study was mead, which is an alcoholic beverage made out of honey and water fermented by yeast, also known as honey wine. Mead can be flavored with fruits, spices, and hops. Second one was white wine, an alcoholic beverage produced by fermentation of grapes. Production is made in anaerobic conditions to prevent the fruits from spoiling. Moonshine, a high-proof alcoholic drink produced in amateur conditions, typically obtained by batch distillation from alcoholic fermentation mash, in anaerobic conditions, made out of sourdough, water, sugar, and yeast. Vodka in this study was made by diluting the moonshine, as opposed to the traditional method of being produced from potatoes or wheat by distillation. Amber vodka is made out of moonshine and amber stones. Amber stones were collected in Gdańsk in Poland. The resin from trees is creating amber stones by dropping into the water. Alcohol with amber stones has a lot of positive health effects, such as anti-inflammatory properties. Benchtop NMR methodology. Method used was an internal standard method. I've tested 3 different internal standards: TSP, acetonitril, and acetic acid. All 3 of them had a uniform and clear spectra. And TSP is an internal standard that is being used most of the times in most of the studies. But it's very, very expensive. That's why I've used acetonitril instead. I did 2 sets of calibration standard solutions from 0 to 90% with acetonitril and deuterium oxide. Then 2 sets of 5 samples with 3 repeats each with use of acetonitril internal standard. Both calibration standards and samples were performed under repeated conditions. GCFID methodology. Method used was a calibration standard method. The calibration standards were made from 0 to 10%. All of the samples were diluted 10 times to reach the calibration standard curve. I've made 3 sets of 5 samples and repeated all of them 5 times. Both calibration standards and samples were performed under repeated conditions that were pre-set up by a technician on University of Derby. Due to Benchtop NMR giving separate results from the ethyl and methyl group, the ANOVA test was done with a 2-key post test. ANOVA test was used to find significant results, and the 2-key test was used to find out which specific groups' means were different. Tests that show that it's better to compare just 2 of the results instead of 3 were additionally tested by an F-test followed by a T-test. F-test and a T-test are showing a difference between 2 variances, while ANOVA test shows more difference between more than 2 variances. The results from Benchtop NMR show the ethyl group and methyl group peaks and the retention times. However, the Benchtop NMR also shows the peak areas of water and the standards used. Water in alcoholic beverages may distort the result of peaks of methyl and ethyl groups, which can affect the result given from Benchtop NMR. GCFID used were pre-programmed for ethanol and methanol in samples, so it can recognize the peaks. All of the samples had results of peak areas of ethanol. However, the sample of moonshine also showed additional peaks that were later on checked for propan-1-ol and propan-2-ol. The results didn't match the database of those peaks, but we still can see that the moonshine have some impurities, and it's not a clean beverage to drink. The study concludes that Benchtop NMR give more precise results for tested alcoholic beverages. Additionally, the results from Benchtop NMR are statistically better than those from GCFID. Further improvement of conditions used on Benchtop NMR has to be made. Improvement has to focus on testing high water contained samples as well as high sugar contained samples. GCFID, in addition to showing the alcohol concentration of ethanol, also shows various alcohol derivatives that can be found in alcohol beverages and are not allowed for consumption. Results from both instruments were very accurate. However, based on differences in results and statistics, the Benchtop NMR stands out in terms of accuracy. To better understand the implications of these results, future studies could focus on testing different conditions under which this study took place, or comparing different instruments to Benchtop NMR, and not necessarily focusing just on GCFID. Thank you for listening and being here, and hopefully you're looking forward to your graduation, guys.